Alright, hello Algebra 2. So today we're looking at angles and angle measure. And just a heads up that we're skipping the part of this where you guys physically measure and draw angles, because I'm assuming that most of you probably don't have a protractor lying around at home, and B, if you don't know how to measure angles by now, I did something really wrong for the past 3 years, because we've been doing this stuff since like 8th grade. So I'm assuming that we're good on the angle measuring part with the protractor and stuff, and we can just move on from there. So far when we've been talking about angles, we've been saying that angles are positive and negative angles aren't a thing. Now they're going to be a thing. Because now we're going to be talking about angles in a coordinate plane. And if I've got an angle, let's say here, what I call that angle depends on which way I'm going around from this point. So this is always the line we're going to be measuring from. So the thing that we're used to thinking of as the x-axis going off in the positive direction, that is 0 degrees. And if we're measuring going around this way, it's positive. If we're measuring going around this way, it's negative, which is kind of backwards from what we're used to thinking. We're used to thinking about like a clock going around, like, positives through this way, negatives would be going backwards on a clock. But positives are this way around from your x-axis, and negatives are this way. Which means there are actually multiple things we can call this angle, which is kind of weird. Because usually when we're talking about graphs, like if this is the point 5,2 or something, that's what that point is. There isn't anything else I can call that point. But if we're talking about an angle, let's say this is 30 degrees. If I'm going around this way, it's a positive 30 degrees. But I could also get to that angle by going around and starting here and going around until I get here. So I could get to that angle, and it's probably more natural to think of getting to that angle by going this way. But you can also get to it by going around this way. How many degrees is that? Now, if you think back to circles, a whole circle is 360 degrees. For a whole circle all the way around. And if that's not something you remember off the top of your head, that's probably one that you're going to want to jot down. So a whole circle is 360 degrees, which means if this part of it is 30, if I start going around the other way, the rest of the circle is going to be 330 degrees. But since we got that by going around this way, it's negative. So those are two different things we could call that angle. But there are actually more. Because we could also get to that angle by starting here. I'm going to get rid of this one for a moment. Because we could also get to that angle by starting here, going around, going through it or past it, going around again, and then stopping at that angle. How many would that be? Well, the whole circle is 360 degrees. So if I go around all the way around once, that's 360, and another 30 would put me at 390. And you can keep doing that, and you can do that on the other end too. So I could say I could get to it by going around negative, by going around this way once, and then another one would put me here, so that'd be 360 and then our 330. So that'd put you at negative, whoops, I want to make sure you don't erase that negative sign. So that's a negative 690. So those are 4 different things we could call this angle. We could call it 30 degrees, we could call it 390 degrees, we could call it negative 330. Or you could call it negative 690, and you can actually keep going if you want to keep going. And the nice thing is we can do this without the circle. All you have to do is add or subtract 360, and you'll get to an angle that's what we call coterminal, which is just a big fancy math way of saying that it's in the same spot. So if you see that word coterminal, that just means angles like this that are in the same place. So those are the same angle. These are just different ways of getting to that angle. That plus 1 with this. So those angles are all coterminal. And again, the nice thing is once you realize that we're just adding and subtracting 360, you don't even need the picture, which is nice. And the phrase that you're going to see that goes within the book is we want an angle with a positive measure and an angle with a negative measure that are coterminal, which is just a fancy way of saying we want a positive angle and a negative angle that are in the same spot as this. So if I've got 125 and I want another positive angle in the same spot, I'm just going to add 360. So 125 plus 360 gives me 485 degrees, and that's another angle in the same spot, and that takes care of the positive one. Check. Now we want a negative one, so that means instead of adding, we're going to subtract. So we're going to take that 125 minus your 360, which gives you negative 235, and again, feel free to plug that into your calculator. Now, those aren't the only angles you could have. You could add another 360 and another 360, or subtract another 360 from this one, and you'd get another positive and another negative. In general, it's going to be easiest just to add until you get to your first positive thing, or subtract until you get to your first negative thing, but you can keep going if you want to. Alright, same sort of thing. Let's say we've got a negative 45 degrees. If I want a positive angle, I'm going to take that negative 45, and watch out, that negative is important. So I want to add a negative 45 to a positive 360. So that negative goes with the 45, plus a positive 360 gives you 315. And we're in degrees. And same sort of thing with a negative. So we're going to take a negative 45 minus 360. Which gives you negative 405 degrees. Cool. And the reason you want to make sure you keep throwing those degree signs on there is because now we're going to talk about radians. So pretty much everything we've been doing with angles so far has been in degrees. Radians are just another way of measuring them. And the radian part is coming from the idea that the circumference of a circle is 2 times pi times your radius, which is why a whole circle, which we're used to thinking of as 360 degrees, is also 2 pi radians. So 360 degrees is 2 pi radians. So that's just another way of measuring, like inches and centimeters. So this would be like inches, that'd be centimeters, or feet and yards, or liters and gallons. So this is another unit of measurement. So it's another system. And if we want to make this a little bit simpler, these both divisible by 2. So 180 degrees is pi radians. And what we're going to do with this is we're going to use this to change from one to the other. And in order to do that, we're going to make a little fraction. So if I said something like 12 inches equals 1 foot, you could say you've got 12 inches over 1 foot if you want to change from one to the other. We're going to do the same thing with 180 degrees and pi radians. So that's the thing we're going to be multiplying by to get from one to the other. Or, on the other end, you could also say pi over 180 degrees. Just like this one, I could say 12 inches are in a foot, or I could say 1 foot is 12 inches. So we're really just converting units here. Okay. So then if we're going from degrees to radians, then you want to make sure we're using the right one of those fractions. So if we want to start in degrees, end up in radians, we're going to multiply it by pi over 180. And that might be something you want to jot down. So if we're going from degrees to radians, this is the one we want. If we're going from radians to degrees, we're going to want the other one. And we're going to do that in a moment. So if I want to change 170 degrees to radians, we're going to take this times pi over 180 degrees. Your degrees are going to cancel each other out. So now we get 170 pi over 180. And then we're just going to reduce that. And if you happen to notice that since these both end in 0, we can just lop off that 0 and say this is 17 pi over 18. Cool. If you didn't happen to see that and you did 2 and then 5, or 5 and then 2, that would also work. The thing you probably don't want to do, I'm not going to mark it wrong if you do, but you really don't want to turn these into decimals, because anytime you have pi, the decimal is going to keep going on and on and on forever, and that's not really very helpful in terms of figuring out where this angle is. So I really wouldn't turn these into decimals. If you're double checking your answers in the back of the book, they're not going to have decimals, they're going to have this. So just a heads up. I mean, there's nothing technically wrong if you turn it into a decimal, it's just not the most useful way to look at it. Okay, so let's say we got negative 405 degrees. We're going to do the exact same thing. We're going to take it times pi over 180 degrees. Your degrees are going to cancel each other out. And watch out for, if this is a negative, it just needs to not disappear. So your negative is going to stay a negative. So we got negative 405 pi over 180, and no, it doesn't matter whether that negative is here or whether that negative is out there, it just needs to be somewhere. And then we're gonna reduce that, so we're looking for the biggest thing that goes into 405 and goes into 180, and if you happen to see 45 right away, you can save yourself a little bit of time. If you don't happen to see 45 and you just keep going down a little bit at a time, that's fine, but if you happen to know that 405 divided by 45 is 9, and 180 divided by 45 is 4. You can save yourself a little bit of time. Now, if you didn't know that they're both divisible by 45, and you saw 5, or you saw 9, or you saw 3, that's fine. You'd eventually get here. But we do want the reduced version here because, I mean, we don't know really what 405 over 180 pi looks like. And again, negative can be either here or out here. It just needs to be somewhere. Okay. Now we're going to go backwards. So let's say we're starting off in radians and we want degrees. So instead of multiplying it by pi over 180, we're going to multiply it by 180 degrees over pi radians. And the nice thing about that, and the reason you don't want to turn either of these into decimals, is because those pi's are about to cancel out. Because I got a pi up here and a pi down here, those are gone. So now all I've got is 180 divided by 6. Well, that's just 30. And boom, there we go. So don't change your pi's into decimals. Just a heads up that if you did, and if you rounded those decimals, you might end up with something close to 30, depending on how you rounded them and how many decimal points you gave them. I would just not turn them into decimals in the first place, but, I mean, technically it's not wrong if you do. Okay, let's do one more of these. So we're taking 17 over pi over 12 times 180 over pi. And you can always tell if you have your fraction the right way, because if you're going from radians to degrees, your pi should always cancel. That's the idea. We want to get rid of the pi if we're going from radians to degrees. So you're always going to want that on the bottom so we can get rid of it. Just like if you're going from like 12 feet and you want to change that to inches, you're taking it times 12 inches in 1 foot, and then your feet here and your feet here cancel. That sort of stuff that we've been doing since like 6th, 7th grade. Same thing here, it's just another unit conversion thing. Okay, and then we got 17 times 180, whatever that is. 17 times 180 is 3060. Divided by 12, which gives you 255. And that's in degrees. And again, you do want to get in the habit of putting degrees there, because now we are dealing with both degrees and radians. And yeah, technically you should also have like radians on the end of this. They don't really do that. So, I mean, if in general, if there's a pi in it, it's radians, and you don't usually actually write out radians. But degrees, you want to make sure that that little degree sign is there. Right. And that is pretty much that. We'll be doing some stuff later in the chapter with what you actually do with this stuff. But for now, go ahead and check out the homework in the description below, and I'll see you in the next video.